All right, class, welcome here to section 2.2. That's graphs for qualitative data. So what entails is this, is basically we're going to end up looking at bar graphs. So it kind of outlines it here. So let me point it out. Pie charts and then bar graphs. That's what I want to emphasize here in this material. It's kept pretty simple. There isn't a lot you can do to display or talk about qualitative data. One of the things that outlines here in the notes, and I'll highlight this, it says that two graphs are used to display qualitative data, or what I just mentioned, pie charts and bar graphs. So those two graphs are found more often than maybe other types of graphs that get talked about. When we get into section 2.3, that will be more about the histogram, the dot plot, scatter plots. Those things aren't looked at as much in that because these type of graphs are a lot more displayed on a website, a news article, magazine, that sort of thing. A lot of people are more familiar with a bar graph or a pie chart and not necessarily the other side of statistics. Those other ones we're going to look at in the next section 2.3 on quantitative data are more for research basis. What we call pictographs are not talked about here because a pictograph is a way to kind of eye-catching. It's not on necessarily the side of research, and then in some ways, or maybe a lot more ways, it can be biased. So I think we've seen some of it. What I mean by a pictograph is, like, I mean, the homework, if you get that type of problem, stacking the candy bars, you know, for how many, their preference on dark chocolate versus perhaps milk chocolate, white chocolate, you know, different types of candy bars and their preference, but they're using a candy bar to stack up those bars of that graph. They're using images to display that. We want to stay away from those issues because here in statistics we get down to the information itself. In other words, it's rather quite boring. I'm not against pictographs. I think they have their place in advertising. Again, that eye-catching moment there when you want to see, like, what is that graph talking about? In design work, it's very important, especially if you're trying to get people to know about your website. So, but when doing research, we want it as boring as possible, showing the visible information that's there. And that's why we're doing this. So in the last section, 2.1 was about taking numbers, or maybe any set, like qualitative or quantitative data, and putting that, organizing into forms so we can finally put it into a graph. That's what we want to do. We don't want to stare at data. That's boring to do that. Once we organize the data, now we can graph it. So we're going to take all the skills that we know from section 2.1 concerning group data and ungrouped data. Those will also be consideration when we get to 2.3 with quantitative data. But here we're going to keep it simple, and I think a lot of people are more familiar. Maybe you can think back as far as the 3rd grade when you were making bar graphs. High school pie charts. This is no different than that. A lot of, even Excel makes these types of graphs all day long. But you have to remember that your data are words. We'll keep it there simple. Categorical data, they're words that you're collecting from people. You can't ask them age because that would be section 2.3, but you can ask them your gender or ethnicity or Do you like the college? Or things of that nature, maybe opinion poll, things like that, where they're word responses. So looking down here at this example, here we're comparing, and this one here is a perfect example because I know in the homework it's going to have a side-by-side bar graph. What we're doing here with De Anza College versus Foothill College is comparing the part-time to full-time in that ratio here. So you could tell here for this is that De Anza here with the frequency amount here, it's it's probably about 2/3 of the part-time. So you can see that there's a lot of part-time student status there versus its neighbor over here right next door in the Bay Area. For Foothill College, it almost seems like the part-time student doubles or maybe even triples the full-time student there. And even that graph there says a lot about those colleges with a side-by-side comparison bar graph. You can tell that both emphasize on their part-time students. It's a commuter type college, what they call that. And what we did there to fill it out with the y-axis is the frequency here. So the frequency for both of those groups gets placed there at the height of those bars. But the x-axis label is the terms here, full-time or part-time. So in other words, a student responded on a survey and said, or the question was, are you a full-time student or a part-time student? We'll define a full-time student as someone who is taking 12 units or more. That's basically defined here in the state of California. But if you're taking less than 12 units, that's considered part-time. So in ways that the district itself can already determine if you're full-time or part-time student. But that label, full-time or part-time, gets reported out. Let's go down to the pie chart. Is the same information here as the bar graph. The pie chart, a lot of the examples look at, I think there's a mistake here in this one. Looks like they left a percent sign off of that. We'll just include that in there. There should be a percent sign on that, as that's the complement of 71.4. But anyway, the pie chart. Percentages. They don't have to be percentages, but a lot of times they are percentages. That's because they go along with this term called relative frequency. So with the bar graph, we'll go ahead and indicate here that this is a frequency. Sliding down here for the pie chart, these we used here, these percentages are relative frequency. Relative frequency, and I push my students all the time to go back over those concepts. What's the difference? Ask yourself now, do you know the difference between frequency, relative frequency? Do you know how to find a frequency? At this point, do you know how to find a relative frequency? So for your convenience, that's already been done here. And again, to iterate that concept, in order to find a relative frequency, the first thing you have to do is find the total. That's already been done here in this example. So each one of these numbers here for full-time and part-time at De Anza College, I divided by that 22,496 to get the percentages over here. So these numbers are our converted relative frequency into a percentage format. That's what gets used, labeled on the pie chart. So dividing this up here, frequency, bar graph, and relative frequency, pie chart. Now honestly, they're both interchangeable concepts with one another. There is no reason why frequency has to be a bar graph and relative frequency has to be tied with a pie chart. You can mix and match these all day long. I'm just saying that typically frequency is reported for a bar graph, typically relative frequency is reported for a pie chart. And the same thing is true here over here for Foothill College. We have the total here, the 14,100, and that should be, there's another typo there, that should be, probably be 53. I took that out of conversion there on Microsoft OneNote, so that should be a 5. So hopefully I'm not wrong though. But what we end up doing is, again, taking each one of those numbers and dividing by that total to get a relative frequency conversion. And again there, to iterate this, bar graph, pie chart, frequency, relative frequency. And when comparing two groups to each other, that's where I got that comparison here. Side by side bar graph. Usually it's done between like male and female genders, like psychology stuff, issues with that. The side by side is great for the bar graph. But here the pie chart, you just naturally divide it up into its little wedges. And, you know, kind of looking at here, like the first one, you kind of color coded between the part-time and the full-time students. The full-time 59.1%, the part-time 59.1%, the full-time 40.9%. Both of those percentages need to add up to 100%, and they do. And the same thing over here for Foothill College, 71.4% are part-time and 28.6% are part-time. Those numbers come again from this thing, this whole thing. Remember, all of this is our frequency distribution. So let me label that there. Again, this is called a frequency distribution. And that's so important, that this information is organized data that helps us make those graphs down below. Cutting to the chase here on this issue is, how do they make the wedges here? How did I know to split it this much for the 59 to 40%, and over here for Foothill 71 to 28%? And what's going to happen is there's going to be another, I'll expand it here for Foothill College. And I don't really expect anyone to do this, but if you wanted to get down to the precise number, we'd have to start talking about degrees or radians to do that. So this is from relative frequency, I'd make a new column here for degrees. I think degrees are a little more applicable than radians, but however you want to break it down there, I think you can just head on over to Walmart and grab a protractor. Relatively easy than you could trying to convert for radians into the wedges there, but all that stuff, that theory there works the same. So for the degrees, what you're going to end up doing is taking those percentages and multiplying that. The total number of degrees in a circle is known to be 360. You heard that someone making like 180 change in their life. You know, that the Babylonians are the ones that are responsible for gathering that 360, because of an equilateral triangle is defined as having 60 degrees in each, but their base system for the Babylonians was 60. Ours is 10. They like the number 60. I don't know why, but it influenced here for the 360. And so all I got to do is come over here and multiply those two numbers together and grab a protractor and go ahead and get started. So this first one here, take the decimal format of that percentage, 28.6, and if I divide that by 100, I go back to its decimal format, then multiply that times your 360. Done. So this is, I guess I'm going to go ahead and round that to the nearest degree. I mean, we're really close to 103 here, so why not call it that? This is 103 degrees. Let's gather the next one there, 71.4%, 71.4. Divide that by 100. There you go. Multiply it times 360. Done. So we'll round this one 257.404 degrees. So 257. Of course, this one, kind of like the total of the frequencies, is the sample size. The total of the relative frequencies is 1 or 100%. And in this case, the total of the degrees needs to be 360. So, and that certainly is the case here. Now what I can do is grab a protractor from the center of the circle here for Footline College and precisely map out the degrees that I need to use in order to partition the full-time to part-time students. So that's kind of where that comes from. But for in today's age, even though I'm having you folks do that by hand, you can just more or less eyeball it here. You know, that 28.6% is almost a third. You're making that first part there of a peace sign, and then the remainder of it's everything else. So I don't require any of you to go get a protractor. If it really bothered you, you could certainly do that and make that conversion degrees to use a protractor to get a precise amount. But programs like Excel, there's all kinds of online type programs that if you put your qualitative data into it, it does that automatically for you. So that's my little rundown there, introduction to qualitative data. And the next one, what I want to do is look at this special type, one more graph called a Pareto chart. You don't want to miss that at all. All right, so stay tuned for that.